Welcome, everybody. My name is Einstein Millan. I am a software architect and data architect here at White Prompt. And today we're going to do a small dive into Llama 3 and why it's important. It's going to be a little bit hands-on, not so much theory or presentation as much as hands-on. Just subscribe button and give us a like. We greatly appreciate that. So what is Llama 3? Llama 3 is it's a large language model that is structured into two primary configurations. It comes in two flavors, which is the 8 billion parameter flavor, as well as the 7 billion parameter flavor. And it's tailored to be applicable in many diverse AI applications. So this model is engineered to deliver superior language understanding and reasoning skills. And it's been trained with the public internet data to be open source, to be extremely performant, and it's very promising. I was looking at another video posted by Mark Zuckerberg where they were training the Llama 4 model towards the end of this year that encompasses 400 billion parameters. So why is it important? Here's a few benchmarks, so to speak, where we see the importance of the strides that have been and hurdles that have been overcome along the training of this particular model and how it performs with respect to Mistral and Llama. It's superior in every metric, pretty much, except the Llama B by a slight margin. So let's go into this page for a little bit and take a look at some more metrics. And this is the Meta website, and there's a few takeaways on how it focused on the takeaways from this release. So, excuse me, they have cybersec eval, meaning that they're to be looked at as either a good thing or a bad thing. They kind of censor the content to make sure that you're within the guidelines and within the responsible usage of the large language models. They're going to be available in Google Cloud, Hugging Face, Kaggle, Azure, Snowflake, US. It's multi-language, meaning it also understands Spanish and many other languages, very similar to what GPT models can do. That was not the case for the previous Llama models. It was not proficient in Spanish, for example. And so, Spanish speaker here, I think it's important to cover most languages. Their goals is to build an open model. And oh, by the way, the important thing is it's so fast, you can actually type the prompt, and as you type, it builds images for you. Very high definition images for you. It's super important and super powerful in its speed. Here's how it performs with respect to Claude Sonnet, which is supposed to be a huge model. It performs better in almost every metric with respect to the rest of the models. Here are some benchmarks. It's superior in almost every metric except for the GPT suites flavors as far as the quality of the responses it gives. But if we look at, for example, where is Llama 3, the 70 billion parameter model, it performs slightly under Claude and underneath GPT-4 Turbo. But by the same token, the Llama 3 70 billion parameter model performs faster than GPT-4 Turbo and slightly slower than GPT-3 Turbo. But the Llama 3 8 billion parameter model is lightning fast. It's super fast. And so here's where we have the pricing. Notice how much, so for 1 million tokens, GPT-4 Turbo charges $15, whereas the Llama 3 model for the same amount of tokens charges you 20 cents on the dollar. Huge price difference. And if you look at the closer model, that's the 70 billion, it's over 15 times cheaper, but performs pretty close to the model. So this open source sounds promising. Let's see what the price looks like for the Llama 4 model coming out later this year. And I'm also curious to see how well it performs with respect to speed and quality of the responses. So I prepared a little bit of hands-on. We're gonna use Grok, and we're also gonna run the model in my local computer. Now, my local computer does have some pretty nice specs, and 128 gigabyte of DDR4 RAM, I believe, and I'm running on a about 6 gigabytes of memory, of GPU memory, as well as a SSD drive and 32-thread processors. So what I'm trying to say is that these language models, even though it's only the 8 billion parameter model, it performs quickly, but you'll see the difference between running it on good infrastructure versus running it on my computer. So it's a high-end model, be considered a high-end model, doesn't perform as well as the processing power they have at Grok, which is a Meta partner, by the way. So create an API key. Yeah.
So, sorry to interrupt. It's actually Grok because let me tell you something. At first I thought it was X AI, which is
Yeah.
also called Grok but with K. But then I realized it's not. It's a different thing. So Grok with Q.
Grok with Q is a partnership between this company called Grok and Meta partnered together to democratize how we open source models or how we use these open source models. So kind of like when you go to OpenAI, you create a key and it allows you to talk to the GPT models or to interact with the GPT models. Grok is doing the same with Llama, but you can see that it's a lower price. They offer their processing power, and it makes it really easy. As you can see, the graphical user interface, it lets you choose the model from a few models: Mistral, the 70 billion, the 8 billion, and this Llama model. They've decommissioned the Llama 2 70 billion one in favor of the Llama 3. So yeah, it just allows you, rather than run this on your hardware, you should run it on you talk to an API and you send the prompts and it gives you responses. I've already created an API key.
Thank you.
Yeah, sure. And you install Grok by doing pip install Grok pretty much. So something I did yesterday. So basically you run pip install Grok and you're set to go. And they even give you a boilerplate, which I've literally copied from their website. Import Grok. And this is pretty much your role. You can be user, you can be system user, you can be a system role, meaning that's a computer that it'll interpret it as an internal prompt for the model. But in this case, it's us sending a question. And we're going to ask it to explain the importance of fast language models. So I'm just going to run the Python file pretty much. Sure. That's how fast it responds. It just took a second. And we asked it the importance of fast language models. Increased computing power, increased data availability, significant opportunities for training and fine-tuning the models, improved algorithm. So what they mean by improved algorithms is that the models can become smarter with smaller architectures and faster given the same parameters and the same computing power. So these models and the way they process information is also constantly being improved. And that's the effort that they're doing at Meta right now, is making sure that all of these models are democratized and making them available for companies, countries, or individuals to build their own models based on these Llama models, meaning you can fine-tune them, you can train them to be better at certain tasks. Yeah, so that's how easy you can get started with Grok. And they have a free tier, meaning that if after you go over a certain threshold, they'll start charging you. But as you know, the price for these models are much smaller. The fine-tuning is much cheaper. So it's recommended, and I'll answer a few questions, or I'll give a few conclusions about how this is important for especially agentic large language model applications. And what I mean by agentic and graph-like applications, it means that you have specialized nodes that do maybe one or two tasks, but they do them very well through the fine-tuned models that are specialized for those tasks. So I'll go over that in a second. Presentation. So we've provided the API key to the prompt in the code. We've selected the model that we wanted to use, and you can see right here we've selected the Llama 3 8 billion parameter model, and we've provided the key via I'll change that key after this meeting, after this recording. So yeah, and then we've gotten the response from the model. Oops. Now, I'm going to show how we can also run this locally in case we wanted to perhaps train models locally or interact with models locally. And for that, I've chosen Llama. So Llama is pretty much designed to do that specific task of running the Llama 3, the 5, the Mistral, and Gemma, and other models on your own and customize them on your own machine. So you pretty much come to the site of llama.com, you hit download. I downloaded the Windows in my case, and then you just run it as an executable. It runs on your, in my computer, since it's a Windows machine, it runs on my, it runs as a service. And then you just go to your command line and you type Llama 3, and this is just going to run the Llama 3 8 billion parameter model. But you can choose, depending on your hardware, you can choose to run the 70 billion parameter model. We're going to look at that in a second. So normally, after you do this, it takes the Llama 3 8 billion parameter model. It's about almost 5 gigabytes. So it had to download the whole thing. I already did that part. And now and that's it. We're running. And I can ask questions like do you German? How do you say good morning? Sure. This is running on my machine. Notice how it's a bit slower than what I just ran in Grok. And this is the smallest of the models. Anyways, we can use this in combination with other frameworks. And I've discussed this in my other tech talks or OTTs, such as LangChain or LangGraph. And I like LangGraph. I've been looking at it lately. I've been playing with it a little bit. And the cool thing about LangGraph is that you work with nodes. And you can have a different language model for every node, meaning that you can fine-tune a model, a small model and very fast model to do a specific task, such as, for example, tool selection. That's one of the big issues we see with the agents right now, with linear agents or cyclical agents, such as the ones we see in LangChain. For graphs, you can have something like just choose a tool, and then we can fine-tune it such that given an input, we just get an output from that node. And it handles a universe of nodes that all have access to universal state. And they can all change the state or update the state or check the state of the whole application. So that way we can train small models for specific tasks. They can talk to each other and answer questions in not such a cyclical way, but more of a graph way. Makes it faster, cheaper, and better performing. It shows a lot of promise. So this is kind of what I had in mind for these type of small, fast models, such as Llama 3, 8 billion parameter or 4 billion parameter. 70 billion parameter model. So some conclusions. Llama 3 is really good at understanding and following steps for all sorts of tasks. It learns from examples and gets better at figuring out what you want it to do, whether that's cooking, coding, or putting things together. Imagine telling it to make a cake and it lists all the ingredients and baking steps. Llama 3 is also smart at connecting the dots between different ideas and coming up with answers. It's like having a conversation with someone who knows a lot about many things. Now, be mindful that sometimes this can be either the 70 billion model. Llama 3 Meta's AI can also turn your words into pictures much quicker, describe a scene, and it'll show you an image that matches right in with your WhatsApp, chat, and Facebook. So you can integrate, since these are Meta's large language models, you can integrate it with WhatsApp. You can integrate it with Facebook. That's really neat. And right now, Llama 3 can work with both words and pictures for some tasks, but Meta wants to make it much smarter with images. By the end of 2024, they're planning to introduce Llama 3, which will be really good at understanding and creating detailed images from text and descriptions. And pretty much what they mean is multimodal. Multimodal can perform other things than just work with words. It can work simultaneously with words, images, and perhaps other inputs later on. So I hope you enjoyed my talk. I don't know if there's any questions or comments.
I have a couple. So first of all, so using Grok would be similar to using OpenAI, but instead of using their closed model, you are using an open source model that they make available. Okay, I got it correctly. What is the bottleneck you have locally in comparison to their infrastructure? Like you mentioned, you have a lot of RAM. It's something about CPU, GPU. Where's the bottleneck?
I think bottleneck's my GPU. It's
Mhm.
it's 6 gigabytes, 3 or 4 years old. The architecture of GPUs is better suited for large language models because we're dealing with vectors, similarity searches and whatnot. So GPUs are better suited for those things. And it's a shame we could use all that cryptocurrency mining power and put it to good use with large language models.
Yeah, and I saw that nowadays there are GPUs that are exclusively for AI. Like, I think there is a model called
Yeah,
A100. Yeah, that's awesome. They might be using some of them.
yeah, yeah. Go ahead. Sorry.
No, go on.
I'm really excited because we're seeing this is exponentially becoming more efficient and better performing. I'm
Mhm.
excited to see what the future brings.
That's awesome. Do you happen to know how privacy is managed on Grok, like in comparison to OpenAI, which is like the biggest? I know it's a flawless thing or just a characteristic about privacy. Do they happen to have something for people to build applications on top of Grok with privacy concerns?
Hmm. Yeah,
Otherwise?
it's really good that you bring it up. Grok has Code Shield, CyberSec eval. They have a bunch of safety tools baked in to the model itself. So, and also Grok does have encryption in flight. It applies much of the industry standards that OpenAI has applied. That being said, the good thing about Grok is that where was I? I'm getting lost in my windows. But anyways, the good thing about this is you can deploy these models on AWS. So you would get on top of that, or Google Cloud, or Azure, and many of these platforms that already have very robust security measures baked in place, meaning traffic would never leave the internet. If you sign up to use Grok, you can run these on AWS.
Okay,
So
interesting.
you get that flexibility from these open source models.
That's great. Thank you,
Oh, thank
Alex.
you. I appreciate it. No more questions? Then thank everybody for coming.